Hello everybody! Welcome to Creating the Basic Adaptable Game Engine Library, Part 9, Rectangle Class Code. In the previous video, we talked about some design considerations we're going to have when we start writing the code for the rectangle class. We talked about making some variables private and controlling access with set methods and the different constructors we're going to have. So, with that knowledge, it's time to write some code. I'm going to go ahead and open up IntelliJ. Still working in the same project I was before, creating a new Java class, and this will be called, of course, Rectangle. Let's make that a little bit bigger so it's easier to read. So within this class, there's going to be a total of 6 private variables representing the top left corner, the width and the height, and also the bottom edge and the right edge. Again, I want to control access to these variables, so I'm going to make them all private variables. So private double left, private double top, private double the width, private double the height. Also, again, just for readability, let's do private double the right edge and private double the bottom edge. All right, now we're going to need to write some constructors, public rectangle to start. Before I write this though, kind of paralleling the structure we used for the vector class, I'm going to create a setValues method and then call that method in the constructors. So skipping ahead a little bit, let's write public void setValues. That will take in a double for the left, a double for the top, a double for the width, and a double for the height. All right, I need to make this a little smaller to fit on the screen now. So, let's see. Just to make sure the code is really readable, let's say this dot left equals left, this dot top equals top, this dot the width equals width, this dot height equals height, and also we'll calculate right. That will be the left, let's just say left plus width, and this dot bottom will be the top plus the height. All right, and we can use this to set the values for everything that we need. So for instance, in the default constructor, where we're going to set everything to 0, let's use this method, setValues. And so in public rectangle, set values to 0, 0, 0, 0. Ah, nice. Let's also create the parameterized constructor, which is going to also use this function, where we can pass in the left, top, width, and height. So let's say public rectangle, same parameters as that function, so double left, double top, double width, and double height. Again, we'll call setValues and just pass it each of those, left, top, width, and height. Excellent. Okay, so we've got default constructor, the parameterized constructor. We have a setValues method, which handles updating the right and bottom. And between the making of the last video and this video, I've been thinking it'd be really convenient actually to, instead of having a set, or instead of relying solely on a setValues method, doing a setPosition method, right, that just updates the left and the top. Again, it's going to be a quick function to write because in order to set some values, we can always call setValues. Right, so this will be used to update the left and the top, and it will preserve whatever the current width and height are. So this dot width and this dot height. Right, so this can be used for a moving sprite, right, if you need to change the position of it later on. And finally, and probably the most important reason, the motivation for the rectangle class in the first place, is to write the overlaps method. And so public Boolean overlaps. That'll be used to determine if this rectangle overlaps another rectangle. Right, as we mentioned in the theory video, the easiest way to determine if two rectangles overlap is by using the separating axis theorem. We'll determine if two rectangles do not overlap, which falls into one of four cases, and then they overlap if they do not overlap. So we'll invert that condition. All right, so here's the code. Let's create a Boolean called no overlap. Again, we can think of this as four different cases. So there's the case where the other rectangle's right boundary is to this rectangle's left boundary. Right? That case is when the other rectangle is, its right edge is all the way over here, and this rectangle's left edge is over here. And so that's one of our cases. So they don't overlap if that is true. Or, let's see, if this rectangle's right is less than the other rectangle's left. Okay, so that's the condition when this rectangle, well, you can just read the code. This rectangle's right edge is less than the other rectangle's left edge. Then we have the case where the rectangles, one is above or below the other. Right? So that was if the other rectangle's bottom edge is less than this rectangle's top edge, and vice versa. If this rectangle's bottom edge is less than the other rectangle's top edge. And there's a lot of nice symmetry in these four conditions. And so if this is true, or this, or this, or this, then the rectangles do not overlap. But the name of this method is overlaps. We're interested in if they do overlap. And so we will return the value no overlap. It sounds grammatically awkward, but it's logically very precise. All right, and this will be very useful to determine when our objects overlap. Now that we've written the code, this is code that we can test, so we should definitely test it to make sure it's working as expected. And so we'll explain how to do that in the next video. Thanks for watching.